Hello everyone, this is Oliver. I'm a consultant based in Berlin, in Germany. And today I'd like to talk about building data-driven websites using the Wolfram language. So I'm not a full-time developer, so as I said, I'm a consultant. We use Wolfram technology a lot in both internally for lots of reporting and analytics tasks, but also in client projects, again, for analytics purposes. And we often face the challenge of building really cool things using Wolfram technology, and then somehow we want to provide that to our end users in a simple fashion. And obviously nowadays, building websites is a very useful approach to doing that. And so we were investigating various ways of doing this, and we found some quite neat approaches. And today is going to be, in a sense, technologically a fairly simple presentation, but I think it's a very powerful approach, which I hope you will also find useful. So it's all about harnessing the power of the Wolfram language for the web. So as you probably know, the Wolfram ecosystem already has lots of powerful features that support web development. The first one is symbolic XML. So you can create XML files, and in particular also HTML files to create web content. So you can, in a sense, write HTML pages in Wolfram language and then serve them to where you'd like to have them. Then the second thing that's really important is API functions. So you can easily make REST-based or web-based APIs available using Wolfram technology and using API functions. Then you have the Wolfram Cloud if you want to rapidly deploy such APIs to the cloud without having to set up a server. We'll see that in a second, and you can use the Wolfram Cloud. And what we like using for lots of internal things is the Wolfram Web Engine, which essentially is a wrapper around the Wolfram kernel that translates web calls into the Wolfram kernel, so you don't have to think about anything related to the web. You can just fully concentrate on writing code. And because we all love the Wolfram language so much and like its power and its powerful features, you know, one of the things that to me arises again and again, wouldn't it be great if you could easily just use the Wolfram language to create powerful and interactive websites without having to leave the Wolfram ecosystem? Okay, and obviously you can build great websites using things like JavaScript and React, and we have such websites, and in some cases that may be the best approach. But given that the Wolfram language is so powerful, especially when it comes to working with anything related to data, sometimes it makes sense just to stay within that ecosystem and to quickly be able to build a website without having to go into external technology. And that's what I'd like to illustrate today, how we approach that. And obviously the key challenge to this is that the Wolfram language doesn't run in the browser, and that's in a sense the challenge to anyone who doesn't want to write JavaScript, is that all the high-level languages that are around, they don't run on the in the browser. And in fact, browsers typically only support HTML, CSS, and JavaScript. And so obviously the key idea then is to generate the content on the server and send it to the browser. But again, that's not so easy because, especially if you're building some modern interactive apps, you need some kind of logic on the client side to deal with the interactivity without having to go back to the server every time, or at least to make that as easy as possible. And so you end up often, if you do write things with back-end code, let's say in Wolfram language, you still need a bit of JavaScript on the front end, and then that means you end up building JavaScript in the back end in your Wolfram language, send back a JavaScript code, and that's quite a hassle, especially when it comes to debugging and formatting and so on. So that's also not a very nice approach. So we were looking for a way of staying within the Wolfram ecosystem, not having to write any JavaScript at all, and just concentrate on building HTML and CSS. And so the question is, how can this be achieved? Now, fortunately, we're not the only people that have this kind of problem. Anyone who likes to program in any kind of high-level language other than JavaScript has this kind of problem. And so quite a few people have been thinking about how to do this. And one approach that we really like that is really lightweight is known as the HTMX library. So the HTMX framework is a very small and lightweight framework. We see that in a second. That lets you build modern web-based UIs with the simplicity and power of hypertext. And so the basic idea of HTMX is hypertext is essentially in our case, HTML plus CSS, of making it very easy for you to just generate HTML and CSS, and it wraps a few of the things you need to be able to do that nicely, things like AJAX, asynchronous JavaScript and XML, into the library. And the really nice thing about the library is it's very small, so you don't need to have to somehow compile the library into something. You can directly embed it into web pages. And so that means that you can, without having to have a sort of compile step for the actual web pages, you can write things in Wolfram language and send them directly to the browser. Now, I know that sounds very abstract, so let's test that directly. So let's build a really simple page combining Wolfram language and HTMX just to illustrate how that works. Okay, so in a sense, I'm starting from scratch here. So we're going to build a simple web page, and as most of you probably know, web pages created with HTML, they consist of a HTML tag and a head tag, where you can load scripts and set sort of meta parameters, and then the body tag, which contains the actual content of the page. So if we look at the really simple page, what does that look like in Wolfram language using the using symbolic XML? Yeah, so here's the symbolic XML. So we have the XML object and then the XML element, and in this case, it's the top level element HTML, and that contains the head and the body, and I've taken that out and put that into separate variables. Okay, so that's our simple page. It's a very simple page. And now in the head tag, we need to load the HTMX library. Okay, and as I said, the library is very small, so you can load that on the fly, and modern browsers are optimized so it's only loaded once. Even if you have hundreds of pages that call the same package, it won't be loaded down every time. And so in the head tag, you need the script element, and in the script element, you call this URL, which is the URL of the where the HTMX library is kept, and then that's automatically built in. So that's all you need to do to embed this library in your page. So that's your head tag. Now let's create some content, okay? And the content looks sort of is also very simple. In this case, we're just going to, I showed the page in a second. We're just going to create a button, and when you click on the button, we want the server to be called and to provide some content, just to illustrate. And already building a sort of interactive page with a button in HTML and having needing a server that already contains a little bit of interactive logic. And here we can see how that works in using the HTMX library. So HTMX, all it does, it defines some extra attributes within HTML tags, which allow you to call interactive content. So in this case, the button, we have two HTMX attributes. They're called, in this case, you can always tell them as they always start with HX as a prefix. So we have the HX post and the HX swap attributes. What do they say? Well, they say when you click the button, then please call this URL. So in this case, I'm deploying a little function to the Wolfram cloud. So we're using the Wolfram cloud, or abusing the Wolfram cloud in this case, as a web server. So we don't have to set up a complex web server. So I'm deploying a function to the Wolfram cloud. We see that in a second. That just provides a little bit of hypermedia text or hypertext, which is, in this case, going to be HTML. And the HX post tag or attribute, all it says is please call this this URL when the button is clicked. And then that URL provides HTML, sends HTML back to the original page, to the caller. And then the question is, what should the page do with that? And that's where the magic of HTMX comes in, because normally you'd have to think about, how do I take that content and swap it into my HTML page? Well, in this case, all you need to do, you say HX swap outer HTML. So you're saying the button, please replace me with whatever comes back, and put whatever comes back from the server there where the button was. We see how that works and how that looks in a second. Okay, and that's it. So that's my my body. The body of my HTML page. And now let's look at the API function. So this is the function that we're deploying to the Wolfram cloud, which is going to generate content. And I'm keeping it intentionally simple. So essentially, this is just going to, we'll look at more complex examples in a second. This is essentially just sending back some text. Okay, and what I've done here, I've taken the example which is on the home page of the HTMX library, and I'm translating this into Wolfram language. Okay, so this is the content, and now we can test it. So let's export this as a HTML page, and we can do that using this neat little Wolfram language function called embedded HTML, which essentially generates the HTML page and embeds it directly here in my notebook. And I click on this, and this will open the page locally. So let's do that. So here it comes. So this is my page. Okay, so you can already see if you reflect back to what I zoom in a little bit so you can see the button better. Let's test whether that works. Here we go. Here's the button and the click me button. And if you remember, that's what we had here in this in the body. This is the click me button. So when we click on this, we expect to call the Wolfram cloud, get some content back, and replace the button by that content. And the content we expect to come back is this content, okay, because I've deployed that to the Wolfram cloud. So let's look at the page again. So here's my click me page, and this is our first interactive web page built using Wolfram language and HTMX. And please see here that this file it's just a pure HTML file. It's running, it's locally stored somewhere on my laptop, and it's not actually, it's not even being served by a server. So it's a pure static HTML file, which embeds the HTMX library. So I click here, and now this call goes to the server, picks up the server which is coming from the Wolfram cloud, picks up the content coming from the Wolfram cloud, which is this is the content, and replaces the button by that content. So within a few lines of Wolfram language code, using the HTMX library, we've created an interactive page, which I think is sort of very neat and shows how that works, or how the library works. So that was a very simple example. So let's look at a slightly more complex example before we get into the web-driven page, because I really want you to understand the power of this library. So let's build a slightly more sophisticated example. And again, let's start with a neat little example in the Wolfram notebook. So here we've got a nice manipulate where I can play with, I've taken this from the Wolfram documentation. So nice little sign function where I can adjust one parameter and I get something interactive going on. And obviously that's great to have in the notebook, and we know that using the Wolfram cloud, we could directly deploy that to the cloud. But I want to now recreate this interactive page just using Wolfram language and without needing Wolfram notebooks at all, because I want to provide, let's say, I want to provide this interactive page to a client who just has nothing to do with Wolfram technology and doesn't want to install anything and so on. So let's just test this, okay? So first of all, we need an API function, which again, for now, I'm going to deploy to the Wolfram cloud to make it easy. And that function is going to render this plot as an image, as an SVG, and then pass that back to the web page. So let's create the API function. Okay, so this is essentially the same function again, but what we're changing is we're firstly plotting, generating the plot, exporting the result of the plot, which would be some kind of graphics object, into an SVG, which is an image format that is readable by browsers, exporting, and it is also text-based, exporting that as a string and sending that back as a HTML page. Okay, so and this is just an API function, and to make it easy, because I don't want to set up a web server, I'm using the Wolfram cloud as my web server. Okay, so let's deploy this to the cloud. So that's nice and easy. And now we can test the function. Okay, so this is the function running in the cloud, and I'm using the parameter a is 1, but I can now play with the parameter, and it will show me different, as expected. We know how nicely the Wolfram technology works here. We can play around with different parameters and easily get that back, live from the Wolfram cloud. Okay, so that's the function that's generating the content. And now we need a page to display that plot, but we also need the slider that sets the parameter. So again, we're using the same, every HTML page has the same setup. So again, we're starting with a page which has a HTML tag and the head tag, and we can use the same head tag as beforehand, because we're just loading in the HTMX library. And then we have the body, which is going to contain the plot and the little, a slider that's going to show me allow me to manipulate the parameter. Okay, so how are we going to do that? Well, typically in HTML, if you want to sort of structure a page, you use a div element that contains the plot, and we also need a so-called form element that contains the slider that, you know, that in a sense provides the control. So let's look at what that looks like. And this again is already beginning to be a sort of slightly more complex web page. And normally, you know, when we do this and pages can become very complex, you know, we never put everything into one big XML element. You have lots of little parts which is then plugged together dynamically, mostly, you know, like little components which you put together. But for illustration, you know, to illustrate this, I'm just creating one long page that contains this. So first of all, we need the div element that contains the plot. Okay, and here we can already see again the HTMX library, which when the plot, when the page is rendered, we'll see that in a second. It goes to the server and picks up. You know, it needs some kind of initial image, so we pick up the initial image with the setting A is 1 and display that. Okay, and until it's loaded, because it takes a bit to load the image, we're going to show some text which is loading the initial plot. We'll see that in a second. And using the HTMX library, the way we do this, we say, look, we want to, once the page loads, we want to call this this URL to pick up content, and we want to swap, in this case, the inner part of the div. We want to, within the div, we want to put the image, and the div has an ID which is called the plot. Okay, so you can think of having a container for the image which is called the plot, and then we can dynamically change the plots, and it always stays within the same container. And we need this in a second. You see in a second when we look at the form. Okay, now comes, so this is the first element, and what I like to do when I'm writing HTML code in Wolfram language, as you can see here, I like to put in little comments. I know this is the end of the div element because it can become quite confusing if you have sort of more complex page setups, how the things belong together. Okay, then comes the form element, and this contains the input slider, which has a range between 0 and 2 and has an initial value of 1, and it goes up on a step of 0.01. So that's in analogy to the manipulate we saw beforehand, and it contains a button which allows me to run the simulation, because we don't want to, I mean, we could build it in a way that it keeps going back to the server every time I push the slider, but you know, to keep it in a sense to take away the load from the Wolfram cloud, you can change the slider and then you hit the run button, and that's going to go to the server and pick up the new image. Okay, so that's where the input button comes in. And then as soon as you click the submit, then what HTML forms do, they need to know what, you know, what should they do once you click the button. And this is what we have here. It then essentially says, well, please call this this URL in the Wolfram cloud, which is the API function we deployed there just a second ago, and this is the and pass it the parameter A, and then call that function with the parameter A. Okay, so we're using the API function which we deployed into the cloud and calling that, but we're sort of setting the parameter A dynamically, and then we say when that content comes back, please swap it into the inner HTML, but not of the button itself like last time, but this time we'd like to swap what comes back into a particular target, which is in this case the div which we set up here, which has the name the plot. Okay, and that's why up here the div needs an ID so that we can identify it down here. And that's all it is. This is now we've really, in a sense, created a dynamic page. Okay, because we're saying when I click the button, please call content here and replace the original content which was already displayed on the page by the new content. Okay, that's as simple as it is, and you don't need any JavaScript or anything. So let's look at the results. Okay, because I know it always looks more complicated looking at code. Let's look at the results. Again, we can export, you know, export the page and embed it as HTML. I click on here. So here comes my my page. Okay, now it's loading the initial plot, and you can see I click that again just to make sure that you see what's going on. So when I open the page, it starts loading the plots. It calls the cloud, and then it replaces the plot. Okay, so again, let me zoom in a little bit to make it a bit so you can see this better. So this is my, now looks very much like my original manipulate, but again, bear in mind this is a locally running HTML page, and as a server in the background, we're using the Wolfram cloud. And this image was generated by an API function, which we just deployed to the Wolfram cloud, and it's come back as an SVG. So it lacks a few of the nice features we have in a Wolfram notebooks. For instance, if I hover over this, because it's just an image, I don't get any interactivity. So I'll show you in a second how you can deal with that if you want sort of more sophisticated plots. But it illustrates what we want. Okay, and this is my slider, so now I can change my slider, set it to this setting, run it, and now it goes back to the server and calls the function again, but now with a different value for A. And you can see already this is this is an interactive web page built purely using Wolfram language, in this case using the Wolfram cloud as our server, which is providing the content. Okay, so with a very few lines and using no, in a sense, no knowledge of JavaScript, we've managed to build an interactive site page, and that's all there is really to it. So I could sort of end my talk now, end my presentation, because I've already demonstrated how to build an interactive site using Wolfram language and HTMX, and everything else is just in a sense expanding on that basic functionality and make it more interactive. And I'm going to show you an example just so that you can see that you can build really really powerful things using this approach. Okay, so let me get back to my my presentation. So I think you've seen the basics, and to be honest, I mean, all I really I think all our pages just use these few little so-called HTMX attributes, and I think you'll find that in total, I think HTMX only defines about 20 attributes, and that's it. So it's a really, really small library, but it provides exactly what you need to give you this interactivity. Okay, so let's go on to the next part of my presentation. If I manage somehow to click onto the next page, for whatever reason that's not working, go to next slide. There we go. Okay, so you've seen the basics. So let me just do a little quick recap. So how do you build a data-driven website using only Wolfram language and HTMX? First of all, the key Wolfram languages features you need a symbolic XML to create the HTML content. Use API functions to make functionality accessible on the web. And then we were using the Wolfram cloud now as a demo, but in reality, if you want to sort of host an independent website, then it's much better to use something like the Wolfram web engine, which sort of wraps the Wolfram engine provides a wrapper to the Wolfram engine that sort of marshals web calls into the Wolfram engine and converts them into API calls to API functions. Okay, so that's just a simple wrapper library. It's actually a Python library, but you don't actually need any Python code. All you do is set up the Wolfram web engine, and then it calls the code in the Wolfram engine. And then as a third-party technology, use HTMX for what I just demonstrated, partial updating of web pages. So the key idea here is you have one page, but you can selectively change parts of that web page using the techniques I just illustrated. And then when you want to make sort of slightly more sophisticated and nice looking web pages, you need some kind of styling. And the styling languages for web pages is CSS. And we like to use Tailwind CSS, which is, there are lots of different approaches to writing CSS. Tailwind is a very nice library that provides so-called utility classes. It makes it easy to put together styles. And then if you want your line charts to be interactive, I showed beforehand that if you just pass back static SVGs from the Wolfram language, then that's a quick approach to setting up a server. But nowadays people raise sort of they like having interactive plots, and so it's good to have a plotting library. And one plotting library that's come out fairly recently that is very easy to use and goes really well together with the Wolfram language is so-called observable plot, which essentially takes data, JSON data coming back from the server and turns that into interactive charts. It's very easy to use and very, very powerful. And it doesn't have any logic. You need to provide sort of the right data and the logic of observable plot just make sure it looks good. And so it fits really nicely with, we find with Wolfram language. If you want to create more sophisticated, or let's say more interactive, they're not more sophisticated, but they're more interactive than the SVGs that you can generate using Wolfram language. Again, we look at what that looks like in a second. So that's all we need. So to create sort of fairly powerful pages, and let me illustrate this using. Let me show you the website before we look in how to build that. So in this case, actually the website is sort of fairly complex in itself, and it's actually a front end for simulation, for what we call an enterprise digital twins. So simulation that simulates, in this case, a consulting company for the demo. And let me show you this, because it started off, this front end started off as a Wolfram notebook. So let me just quickly show you the Wolfram notebook, because that in itself is already quite interesting. So this is the Wolfram notebook. Let me just make it a little bit sorry. Let me zoom in here a bit to make that so you can see it better. I don't want to go into the details of how we built the notebook, but this to illustrate, what we started off with. So essentially what we have here is a simulation dashboard which shows me different KPIs, and I can click through different views of my data, different plots of my data, and it contains some predefined scenarios which I can look at. So I can look at different look at a base scenario, and then I have another scenario which has different data, so I can compare scenarios. But it also has an interactive part. So what we do here, let me just show you, close all this. We have the same thing, the same plots again, but in this case, I can actually dynamically interact with my simulation. And let me just quickly show you what this looks like. So here, for instance, we're using a nice little timeline plot, which is something we really like in Wolfram language, to show you time dependency. So we have, in this case, 3 projects that run from 24 to 26, and then here in the settings I can manipulate those by changing the start and stop time. So you can see down here interactively, if I change that, and then I can click through here, and I'm illustrating this on purpose so that you can see in a second what it looks like in the web. I can change the start and end times of my projects. Let me just finish this, and now I've sort of sequentialized my projects, which obviously means from a consulting perspective that the demand for my consultants will somehow go down. So that's probably bad news from the financial perspective. And then I can say apply the settings, and then it runs to the back end, and in this case we can see that my demand has changed versus if we compare this to the baseline scenario where we had I think full utilization, and then suddenly in the interactive scenario we've changed the settings and we have sort of different demand patterns. So that's, as you can see, a sort of fairly complex application already, with lots of different views, and you can sort of set up lots of different things in the notebook. And this is completely built with as a Wolfram notebook. So now the idea was, how can we provide this to our clients using a web page? Okay, so now let's look at what it looks like in the web page. So it's exactly, in a sense, looks almost the same, but now this is completely built using Wolfram language in the back end, and served as a pure web page in the front end. It's running in the web, so there's a link to this in my presentation, so you can check it out. It's just a demo, okay? But again, now you can see here we can switch between the predefined scenarios and interactive scenarios. We can choose different choose the different settings here, and we can sort of flip through the different views, the different plots down here. So we have sort of fairly complex nested tabbing structure. And what we can also see here, but see, we're using the observable plot library, that these are actually sort of, in a sense, interactive charts, so that I can wander along the chart and I can see the different values here along the chart, which obviously is a nice feature. And that's why we use observable plots. So in the end, what our web server does, or what the Wolfram language server does, it, instead of serving up an image, it serves back the data, and then observable plot turns that into an interactive, or into an interactive chart. Let me just quick sort of illustrate, because there's a few nice little features in here before I get into how we built this. But you can see it's sort of quite intricate, and again, it's built purely using Wolfram language and HTMX and this observable plot language. And to do the styling, we used Tailwind CSS. But look here, we have the same timeline. And here, because I really like this timeline chart in Wolfram language, so in this case, we're actually serving back the timeline chart as an image, because we couldn't find something equivalent in observable plots. So it illustrates how it's great to have different technologies there. And I can now do the same thing as beforehand. So let's go into these projects, just to illustrate that this interactivity, because it is quite sort of sophisticated, because you can now go into an edit mode, and I can sort of edit this, and it's not quite as neat as in the Wolfram notebook, because now I sort of save it, and then it changes down here. Okay, and then I can do project number 2, edit that, change the timeline along here, again save that, and then I get this, and that's just to complete the demo. Let's do it also for the third project. So I move this up here somewhere, save that, and there's my project. I didn't quite hit that properly, so let's edit it again, move it up a notch, save that. So now it's sort of nicely sequentialized again, and now I can again run the simulation, and in theory my demand should change. So let's see whether that works nicely. So now I'm calling the simulation, and again we see the similar demand pattern we saw before, which we would expect, because it's the same, essentially the same application running in the background. So I think this sort of illustrates that using the simple things the simple HTMX techniques I showed you initially, you can build I think a very powerful website with quite with sort of lots of complex tabs, and it's interactive, and you can with accordions and so on. So you can see that you can build something quite powerful, and everything, as I say, is completely based on Wolfram language. Okay, so let me get back to my presentation. So here's the link, so you can directly call this twin.transcentis.com. Actually, the backend simulation is a separate server again, which is just a REST API, and that's actually built using Python code. You could easily build that using Wolfram language for historical reasons. The backend simulation itself runs using it's built using Python library, and we actually have open source the backend simulation, so you can actually look at the code for this. Here's the link to the documentation, and you can look at the code in our GitHub repository, so that if you're interested in the simulation itself, please take a look at that. Now, just to give you an overview of what the architecture looks like, I'm nearly getting to the end of my presentation, so sorry I'm taking a little bit longer. This is the overall architecture. So we have here the web page. We saw that beforehand. We use the Wolfram web engine to serve up to wrap the Wolfram engine, which contains the actual code, and that's purely Wolfram language. And we have to keep the session state in there, and then in the back end we have a simulation server, okay, which is in this case but using Python. And I think that's almost it. Just to give you a quick overview before I get to the Q&A. So if you have questions, please write them into the Q&A, and I'll be happy to answer them. Just to give you a quick overview, so how do you build this sort of fairly complex page? You need to break it down into individual components, and think of each part of the page as a component which you can neatly wrap in Wolfram language code, and each component this serves up certain things, and each component is then represented by an API function which you then can call with different parameters, and it delivers back the right content. So using this library, it makes it very easy to break down complex pages into individual parts, which you then can call or replace individually. Okay, and that's gives you sort of a quick overview of what's possible using Wolfram language, and I hope you find that interesting. And please do take a look at the HTMX library. And let's get to the Q&A and see whether we have any questions. Okay, so one of the questions was, would symbolic HTML be helpful for you, or is symbolic XML enough? And to me, it's fine. It's fine. I mean, if you want to make it simpler, you could create your own wrappers in Wolfram language easily. But I find it's easy enough because, as I say, we break things down into components, and then you don't actually see that much of the XML elements because you can neatly wrap them away into components. Okay, and I find symbolic XML is great because it gives me all the power I need to build complex pages. And yes, you can use other HTTP. So the next question was, do you use other HTTP methods other than get and post? And yes, we do. In this case, I don't think we do, not for this example. It's just get and post. But the HTMX library provides all the standard REST HTTP methods, so there's no problem with that. And yes, this can be used with the local web server as the backend. So the only reason I was using for the demo using Wolfram Cloud is simply because the Wolfram Cloud obviously is, for the demo, was right, nice and easy to use as a backend server, and I can immediately deploy functions. But as I said, what we normally do, we have the Wolfram Web Engine, which is a Python library which you can download for free, and we use a Wolfram kernel. We use the Wolfram engine for the actual code. Okay, so when we're testing, everything runs completely locally, so there's no reason to have to use the cloud in this case. And obviously, when it comes to, our server is now running in the cloud, and we've deployed it in a Docker container, and the Docker container uses the Wolfram, the basic Wolfram kernel, Wolfram engine Docker container provided by Wolfram itself. Okay, so we use that as a basis, and then we build our code, build our Docker container on top of that. And as I said, we use the Python library, Wolfram Web Engine, to serve that. Okay. Why not prototype in Wolfram and replicate elsewhere? Well, that's what we did. I mean, yes. Yeah, I mean, so one of the questions: why not prototype in Wolfram and then replicate elsewhere? Yes, you could do that, but to be honest, I mean, why would I want to do that? The Wolfram language is, to me, a great language. You can deploy it everywhere, and it's much faster in my experience building things with the Wolfram languages, because it has a few sort of unique functions which you can't sort of easily find in other languages. And to be honest, I know very many. Over the years, I've used very many programming languages, and I always miss the Wolfram language if I'm forced to use some kind of other language. So to me, there's no reason, and the only reason might be from a financial perspective, I guess, if you have to, when you're paying for the kernels, if that scales up. But I found, we have a number of Wolfram kernels, licensed Wolfram kernels running in the cloud, and it's not that expensive. And the time I save, or the time we save in maintaining the code, is much larger than what we pay per year for the license. Okay, so yes, you could replicate it somewhere else, but to me the question is, what's the point? There's no reason for me to do that. And then how can I integrate this into Google Sites? Well, I don't know much about Google Sites, but I guess if you mean using the Google Cloud to deploy servers, well, as long as you can deploy Docker containers there. So we deploy everything. We use DigitalOcean as our cloud provider. We deploy everything either on Kubernetes. So this example is actually running on Kubernetes. So we have our Docker containers running on Kubernetes, but you can just as easily deploy it to a Linux server. If you're talking about a sort of pre-built, if Google Sites is a pre-built web package, then that's probably not going to work. Yeah, but the easiest thing to do is just to create a Docker container and then to deploy that, because the Docker container itself would be the website. Unless you're just serving static pages, like I illustrated before, and you could create just purely static pages, which then call some kind of server backend, you could do that. But then the question would be, where do you run your backend code? Somehow you've got to deploy that. Yeah, and typically you can either do that using Kubernetes or run a Linux server that is running the Docker container, which is very easy to do. It's modern cloud technologies. It's easy to use. Okay, so that's I think I've gone through all the questions. So sorry again for taking slightly longer than I should have. I hope you enjoyed the talk. I certainly enjoyed presenting it. Please download the notebooks. I've also, by the way, in the notebook provided the link to the interactive, not just to the interactive web page, but also to the interactive Wolfram notebook, which is also available publicly in the cloud. So you can, if you're interested in that, you can also look at that. And I'm also happy to connect up either here at the conference, or please get in touch with me via LinkedIn. I'd be delighted to connect with you and to answer any further questions if you have them. Okay, well, thank you very much, and I hope you enjoy the rest of the conference, and hope sometime to at least virtually meet you somewhere. I will be delighted. Thank you very much, and bye-bye.